Salutations, chemistry peeps. Alright, let's talk about barometers. So, you've probably heard of barometers at some point in your life. You've for sure heard at least the term barometric pressure since you live in Oklahoma, and every spring and sometimes in the fall we will hear about barometric pressures all the time. If you're watching the news as the tornadoes come rolling in, they'll talk about barometric pressure. And what the barometric pressure is talking about is actually atmospheric pressure. It's a measure of the pressure of the atmosphere. The way that a barometer, which is what measures barometric pressure, the way that a barometer works is you have a glass tube that you have evacuated. So there is no gas in here. There's nothing at the top of the tube here to push down on the mercury that's in the tube. So you take this vacuum filled, if you want to say it's kind of a misnomer to say it's vacuum filled because there's nothing there. So it's just an evacuated glass tube, and there's an open end of the tube down here. So this end of the tube is closed, but this end of the tube is open. And when you stick the open end of the tube underneath some mercury and then expose the barometer to atmosphere, what happens is the atmosphere, because it pushes on everything, the molecules that make up the atmosphere are going to come in here and they're going to push on that mercury. They're pushing down on the mercury. Because they're pushing down on the mercury is going to try to go somewhere, since something's pushing on it. That's what things do. If you push on them, they try to move, if they can. And so because we're pushing on the mercury, or the atmosphere is pushing on the mercury, and because there's nothing in the tube to push back, the mercury flows up the tube. Now, it won't do that indefinitely, because while there's nothing up here pushing down on the mercury, something is pulling on the mercury. And if you thought about it for a minute, I bet you could figure out what it is. So there's no gas pushing down, but there is something pulling, and that is gravity. So gravity is pulling on the mercury. It doesn't want it to go up the tube, because mercury is very dense. Gravity has a pretty good pull on the mercury. And so it's essentially a tug of war. The atmospheric pressure pushes the mercury up the tube, and gravity tries to pull it down the tube, and wherever they equal out, that height that the mercury goes up the tube is the barometric pressure. It ran out of room there. Barometric, pretend there's a C there. Pressure. Sorry, I am not drawing this well. Barometric, and we'll put the pressure on the top there. So anyway, this is the barometric pressure. That is the height that the mercury gets pushed up the tube. This, by the way, is where that weird unit, millimeters of mercury, comes from. It is literally just how high up the tube does the mercury go. And the higher the pressure, the higher up the tube the mercury will go. And so if there's a big storm coming in and they say, oh, the barometric pressure is dropping, what they're saying is that there's low pressure where we are, so there's less gas pushing against the mercury, and so gravity starts to win out and it pulls it farther down the tube. And what that means is, because there's very low pressure, it means that other gas is coming in to fill that opening. Low pressure is, gases always will flow in to fill in that low pressure region. So that means a storm is rolling in when we have that low pressure. So this is how barometers work. We actually have a barometer in the lab at school, but I don't think we'll be able to go in and see that. But when you hear it on the news, them talking about barometric pressure, they actually literally just have a tube with some mercury in it, and they just read how high up the tube that mercury goes. It's kind of crazy, but and it works out. So let's do a couple practice problems here. We're going to convert from one unit of pressure to another. Oh, there should be a space there, by the way. Inflate 2A, total pressure of 125 psi. So go ahead and pause the video here and work through these two problems, and then when you finish that, come on back and I'll work through it with you. Alright, so the first one here. A high-performance road bicycle tire is inflated to a total pressure of 125 psi. What is the pressure in millimeters of mercury? So because this is just a unit conversion, we are just going to stick in our conversion factor to convert from psi to millimeters of mercury. And if we go back here to our slide with all of our conversion factors, 760 millimeters of mercury is the same as 14.7 psi. So 14.7 psi, that is the same as 760 millimeters of mercury. So my psi cancels out, and if I check my math here, or do the math, I should say, 125 times 760 divided by 14.7, the pressure in that tire is going to be 6,400, and let's see, if I only get that 760, I believe is exact, so I would get 3 sig figs. So 6460 millimeters of mercury. You'd have to have a really tall barometer. A really, really tall barometer, several stories tall. Well, about 2 stories tall, I guess, barometer. Alright, speaking of barometers, a barometer in Denver reads 627.8 millimeters of mercury. What is the pressure in atmospheres? Well, 627.8 millimeters of mercury. If you go back and check that previous slide, 760 millimeters of mercury is the same as 1 atmosphere. So this is going to be less than 1. 627.8 divided by 760 is 0.826 atmospheres. Whew. And that is why your ears pop when you drive up to Denver. It is about 4/5 the pressure here at Tulsa. Excuse me. Tulsa is pretty close to 1 atmosphere. Depending on whether we have a storm coming in or not, it's usually around like 0.97 or 0.98 or something like that. It's pretty close to 1 atmosphere. So that is a significant difference in Denver. All right, so in the next video here, we're going to talk about 3 other properties used to describe gas and how they relate to pressure. We're going to discuss the volume, the temperature, and the number of moles, and how all 4 of these things really relate together. So I'll see you in the next video.